today we'll continue with exponential function. Exponential. Now, the reason we call exponential function is we have this form, y times a times b to the x power. So this variable is on the exponent versus this function. This will be quadratic function. Let's say 3x to the second power, or we could have y equal to 5x, hello, Tanvi, 5 to the x12. Okay, so now you can see the difference between, this is called power function. And here, the function, the variable is in the base. Now here, the variable is on the exponent. So that's why we call this as exponential function. And as an exponential function, as long as you have big enough x, it will always outgrow the power function. But the power function looks a lot at the beginning, but once passing certain numbers, the power function will be was going to be below the exponential function. So, and this, so since we all will go through the COVID, and that basically is what we're experiencing, which is exponential function. Okay, so let's see. If you have the patient zero, and that's just one, the first people that are sick, but he can pass that to two person. So we got another patient, and each one going to passing to another, and then each one get passing to another. So this is actually 1 to 2. So this it's actually quite infectual. The COVID is not as worse as this. COVID is one person passed to 1 point some person. Okay, so if we say this every day, we have the people passing to 2. So our function will be y equal to 2 to the x. Now, x is number of days. Now, we can see that on the first few days is not that bad. So this is our x, this is the y. So of course, when x is 0, 2 to the 0th power is 1. That's our first patient. Then after 1 day, we got infected, or we got 2. Then second day, we got 4. And third day, we got 8. Each time multiply 4 and 15. So you can see that it doesn't look that bad. But eventually we're taking off. So let's see. After, say, after 30 days, so X is 30. Can you guess how many people will be infected on that day? Just something you think. Just have a guess. Based on what you see here.
I don't really understand.
A million, a billion? So you can see that the first, at the very beginning, we had 1 patient. Then after 1 day, we got 2 new patients.
Mm-hmm.
After second day, we got 4 new patients.
Okay.
After third day, we got 8. So that's basically this function, y equal to 2 to the x power, not power.
Oh, okay.
Y equal to 2 to the x. So that's why it's called exponential, because x is on the exponent. Now, after 30 days, how many new patient will have? Can you
Uh,
give a guess?
Maybe a few million.
Okay, someone said a million, and anyone? Well, everyone give a number, okay?
10 million.
How many?
10 million.
10 million? Okay, we got a million, 10 million. And
2000.
who said 2,000?
Me.
Okay, and we said 2,000. How about Osher?
I'm gonna go with 107 million.
107 million. Okay. Well, if you have a calculator, does this one have a calculator? Uh, more tools. This one doesn't give us a calculator. That's not good. Okay.
You might be able to find it in apps
Yeah,
along the bottom.
yeah, there's an app, loading
Might,
app. Do they have a calculator on this?
I could see you might be able to add it. Yeah, there's a wait, I guess there isn't.
I don't see it. Anyway, oh, add app. So this is the add app. Okay. And we see a calculator. Okay. If you have a built-in calculator, so you can see it. Calculator.
I can't find one in the apps area.
No. Wow.
Yeah, that's huh.
Yeah, that should be something pretty easy to add to
Hmm.
it. Anyway, well, I'm just use the calculator on the my computer. This is a 2 to the 30th. Okay, let's see how big that is. Okay, I'm going to write this out. And you actually can also try on your side if you got computer there. So this is what I got. Okay. Well, we got 1,073,741 and 824. 1 billion. Yeah. So that's something about exponential power is growing, and pretty soon you have a lot of people get sick. But of course, in real life, um, at the very beginning, it's exponential function, but eventually it will taper off because um, we just have, limited number of people. And this kind of, let me see, this kind of growth is what you see in the nuclear bomb. A nuclear bomb is basically, well, let's took the first kind of nuclear bomb is called fission. Oh, right.
My interest now.
Fission. So, which basically you have a neutron, and that hit a plutonium atom, and that will split out, let's say, two neutrons, and that hits another atom, then that gets split. So as you can see that pretty soon we got a lot of neutrons kind of bouncing off each other. So that's why the nuclear bomb is very powerful. Is because pretty soon you get, I don't know how many, but huge numbers of neutrons. And each time when they break a plutonium atom, they release a power, release some energy, and that energy get added up pretty soon, pretty fast. And eventually you have a bomb which when it go off, it can kill the whole city or the population of the whole city. So it has to do with exponential growth. Okay, so that's why, like when you have pandemic, uh, when you have those kind of virus going on, you got to be very careful. You have to have the protections and all that, and you have to be really make sure the hospitals won't be overwhelmed. Okay, and on the other hand, you can also work for us, like say nuclear power. We can use that. We can use that's why we can use nuclear. Uh, uh, Basically, think about the power we got. Uh, the explosion is not necessarily a bad thing as long as it's controlled. Now, you guys drive cars, right? No, not yet. No,
Haven't started yet.
okay.
I did.
Now, in the car, if you drive, we call this, if you use gasoline, and that's called internal combustion engine, internal combustion engine. What's really happening is explosion. Okay.
Yep.
And but as long as explosion is contained, it's controllable, then we can use that to in this case, to move our car around. And same thing, nuclear power, if it's controlled, then we can use nuclear power for our benefit. We can use that to generate electricity, and then we'll use that. Of course, we use that. All of us use that at home. Uh, and another way this can work for us is last time we talked about when you invest, and there is something called uh, compound interest. And so we talked a little bit about that. So we could just go a little bit in depth. For example, if you got $1,000, that's your principal. You deposit. Now, if we want simple interest, simple interest is that the interest is on the principal. The interest you earn does not generate interest. So therefore, we see that, so we have, so this is our time. Time zero, of course, we got 100. 1,000, that's what I put in. And at end of year, let's see, our interest is 4%. At end of year, we got 1,000 times 4%, and that give us $40. So $40 plus 1,000 is 1,040. And how about the second year? If it's simple interest. Now the interest is only on the principal, which is 1,000. So that means each year we generate $40. So the next one, 1,080. And on the third year, we generate 112. So when you write this function, let's say our y1, and our y2 is compound interest, y1 is simple interest. So y1 then is 1,000 plus 40t. Yeah. Okay. Are we good on this one? Yeah. Okay. Jed, are you good?
Let me see. Yes.
Okay. Now, if it's compound interest is different. It's going interest. The first year is the same. It just 1040, but second year, the 4% is on this, not just on the principal. So when we got that, we got 1040 times 4%. Then we got 41.6. So we add 1040. So we got 1081.6. Now you see that only $1.06 difference. So for the first year. And when we got to the our third year is going to be the interest is on this. So that's why I call it compound interest. It's interest on interest. So we got that times 0.044%. Then we add up back to 1081.6. Now this is 1120 4.9. Okay. Okay. Well, now that's only $4.03 off. But what is the function of this one? Now the function for this one is 1, y equal to, we got the principal. Now the first year, after first year, we got this 1 plus the rate, which is 4%, which is 0.04. That is after 1 year. And for the, oh, sorry, after 1 year here. Then the next year, our interest is on top of this. So this become our principal. So then the interest plus principal will become 1 plus 0.004. That's for second year. Okay. This is for the second year. On the third year will be the whole thing multiply 0.04. That's for this year. So therefore, what we got here is y equal to 1,000 and 1 plus 0.04 to the t. Good? Yeah. So now you can see the difference. This variable here is 40 times t. This is a linear equation, a linear function. But on here, our variable is on exponent. This is exponential function. Okay. Yep. Well, you can see that on the first few years, there's not much different. Now we're going to see what happens after 40 years and what's the difference. We got so when t is equal to 40, what we got, so t is 40. Our top one, let's say this is 40 years here. And the top one will be y sub 1 is 1,000 plus 40 times 40. And 40 times 40 is 1,600. So that would be 2,600. Now, what happened to our second one? That will be 1,000 and 1 plus 0.04 to the 40th power. And so 1.04 to the 40th, then times 1,000. So we got 4,801. Good. Yeah. So even though it looks like it's the interest on interest is not really no big deal, especially if you're talking about the first 10 years, really that much difference. But once you get a longer time, you have long enough time, when you got 40 years, then you can see the difference now. This is almost twice when you compound interest versus simple interest. So this is something we use in when you invest in something, and so we use say putting some investment you earn certain you call return, and as long as you keep it there a long time, then you actually generate a lot of money. And this also why it is important for you guys when you starting to work, put some money into your retirement fund. Okay, you let the money there grow, and that when you retire, then you have enough money for your retirement. Um, and this is actually kind of nice because you don't have to do anything. You just put it there, and so basically you become an investor, and actually other people work, and you benefit from their work because you invest in them, you put the money in there. Okay, good.
Mhm.
Yeah, have you ever thought about that in when you grow up, when you start working, there are two ways of making money. One is your time. So that's why they talk about like $40 per hour or $15 per hour. Okay. Now, this actually is not really the best way of making money because you trade your time to that. Okay. The best way to make money is to invest.
Passive income.
Huh?
Passive income.
Passive
It's
income or passive income. Yeah. And I don't quite like this term, but I understand why, because you don't have to do anything. But in a way, that sounds, good to me. I don't know. Does it sound good to you, passive income? So what is opposite of passive income? That'll be active income, right? Well, yes, when you're trading your time, you do work. But still, active has a good connotation to it. But when we talk about financial independence, that is really come down to for most of us, we don't have we don't have principal when we start working, unless your parents are pretty rich, so you don't worry about that. Most of us actually have to do this first, using our time to make money. But from there, we got our investment, we have some capitals. And then we put the investment, we actually making money without doing anything because money makes money. So the best way of making money actually is to use our money. This is use our time and talent. But once you get investment, that is you'll use your money to make money. Okay, so that is a way better way to earn a living. Good. But we need to have principle because it is easy when we trade our time to make money, we kind of use that money and buy stuff. We consume it, and then we don't have anything left for accumulate our capital, and then we can get into using money to make money. So that's a discipline. Make sure when we are young, or in your case, when you are young, don't waste money. And if you can save money and put investment, and that money will work there for you. You don't have to do anything. And that money will grow, especially in this country. When you invest in the stock market, and it will always make money for you. Other countries, very hard to say. Like my brother-in-law, he invested stocks. I mean, he lives in China, and now their stock market is just very bad. I mean, it has been very bad. So right now, he basically has been investing money for more than 20 years, and ends up actually he was losing money. So the money didn't grow. Instead of growing, actually the money become less valuable, and also the inflation, and that would kind of uh, make your money worth less. Okay, here's a question for you. Now, when you go buy stuff, you notice that everything is going expensive, right?
Mm-hmm.
Now, is it the things become more expensive, or our money become less valuable?
Money becoming less valuable.
Ladder.
Right. So it's not everything goes more expensive. It's our value, our money goes to become less valuable. And so, yeah, that's something you have to. But fortunately, in the US, if you put in stock market, you always outgrown uh, the inflation. And the worst thing for us to do with money is to put the money under the matrix. That would be the worst kind of, um, use our money. Money has to be used. Okay. Of course, I mean, either you consume it, which is not really good for us, or you use it and put that into investment, let money circulate. And that way you can generate money. And you can see the power of doing that just looking at the exponential function. Good?
I do have just a short question. This one might be dumb, but I am a bit confused.
Sure.
When you do put money in to invest and it, slowly, tediously grows over time,
Mhm.
how does that happen? Like, where does it come from? Like, how exactly does it slowly grow?
Well, actually, that's come down to the stocks. So what is stock? Stock is something that you buy part of the company, and hopefully the company make a profit, right?
Mhm.
So that's how your money makes money. Um, Now some stocks can give you like 100% return in say 3 years, and some companies will lose money, right? Depends on which company you buy. Like say if you actually invested in uh, let's say in Apple. Okay, let's look at Apple stock. Uh, over years, over let's say 30 years. Like that, you don't have 30 years. Let's see if you have. Okay, here is an article. So if you put $1,000 into Apple stock 20 years ago, here's what you'll get today. me see how much we got. Mm. Okay. Now, if you put $1,000 in Apple stocks 20 years ago, it would today be worth almost 530,000.
Wow. Okay.
What?
Yeah.
I believe since for the last 20 years, it's gone up by 50,000%
Sheesh.
in the past
Okay.
20 years.
That's
Well,
nuts.
Well, if you actually invest in Apple, the reason you make money is because Apple made profit, so therefore you share their profit.
So
Good?
you own a percentage of the company.
Right, you own percentage of the company. Basically, buying a stock, you own part of the company. So you get the profit out of that. That's where the capital, right? You invest, you use your money. The money actually makes money. So money is kind of like the gasoline, the gas you buy, and so your car can run. So they need that. Business needs money to get business running, so they can generate profit. Well, this is about Apple. Well, can you guess about let's see, Microsoft?
I'd say that thing's probably skyrocketed.
Over say 20 years. Do I have that? Well, let's have okay. Let me actually show you a picture. That's actually pretty interesting to look at. Okay. All right. Can you see it?
Mhm.
Now you see the stock price. This is the 19. Okay. This is 1991. It's $1.46. Now what's now? 374. So if you invest $1,000 in the 1990s, now you got $374,000.
That's
Good.
okay. That's interesting.
Yep. That's why. But what is the downside when you invest?
I was curious about that.
Well,
Takes a long time.
no,
Well,
it's very risky because what happens?
because if you give them like, let's say $1,000, you are investing, so they own that chunk of your money, don't they?
You give them chunk of money, but you got their stock. So that's exchange. Basically, you lend money to them so that they can use. Good.
Question.
Okay.
Yeah.
In order,
Okay. So if you invest a certain amount of money a long time, like a long time ago,
Yeah.
do they accommodate for inflation? Like if you I don't know how to explain this. So like you make the amount of money that the company makes, like I don't know,
Right.
a certain percentage later. It's like say you invested $100, you have like $1,000 now.
Yeah.
They also accommodate for inflation too, and give you
No. No.
what?
Yeah, they don't factor in inflation. It's whatever the stock price. So basically, you buy stock and you own part of the company, you can make profit, which is called dividend. That's one way to make money. So each year they'll give you some money. Good, that's called dividend. And you also can sell your stock and you earn by the difference. Good. Like when you buy like $100 per share, then later on that share goes up to $1,000, 10 times. You sell it, you make that the difference. Good.
Thank you.
So two way of doing it. One is getting dividend, which is that you don't sell the stock, you keep the stock because you like the company, you believe in what they're doing, that it is aligned with your value, you got dividend. So each year they will give you some money. Another one is,
Get out.
hello.
Sorry, that was my brother again.
Okay.
Another one.
Yeah. Another one will be just like, yeah, you sell the stock. One big thing is we all use Amazon, right?
Yes.
Use Amazon? Okay.
Yes,
Let's
quite
look at Amazon stock over 20 years. See what happens.
So I'm not 100% sure, but do you know if you have to pay capital gains taxes
Yeah.
when you
Okay.
sell a stock?
Right. Well, that's when you actually sell your stocks.
That's what I thought.
Yeah. But the dividend you still have to pay. That's added.
Yeah.
Okay. Now this is the Amazon. Amazon say it's about $2. Some that's about 20 years ago. And now is 180. So 1,000, you earn $180,000. But you can see there's downside of stocks. What happened you bought here? Can you see it? My screen?
Yeah.
Okay, what happened you buy here? That is 163. And the stock crashed. Now it's only worth at 85. But so you lose, you put $1,000 in, now you only got $500. Good.
That's
So that's
not
the
good.
downside of stocks is that you could buy in the wrong time. And you really don't know because some stock just goes up, some stock just like crash. You end up might be worth nothing if some company goes bankruptcy. So how do you deal with that kind of situation? And
Mitigate the risk.
yeah, well, how do you do that?
I truly do not know.
Learning the market.
Well, how do you do that is by multiple of stocks. So if one stock goes to, crash, and other stock can make it up. But the
Index
problem
funds.
is we don't have that much money. And so some people have this great idea is called the mutual fund, is that get people pull their money together. Now we have, millions and billions of money. And then we can buy stocks. So basically, in effect, instead of buying like one stock and two stocks, we're actually buying like a percentage of stock, like 0.01% of Google, 0.02% of Amazon, and things like that. So that's called mutual fund. Have you heard of that?
Yes.
Yeah.
Yep.
So that mitigate your yeah your risk. So mutual fund really something between like maybe 5 to say 10%, depends on how well they run. And but still that's make you don't lose money. If you buy stocks, you could make like 100% or 200% or even 1,000%, but it could also end up with nothing. So for safe investment, just put in mutual fund. You don't have to worry about it. Okay, just every month put some money in there, and those things will grow. Okay, and Asher talked about index fund. Index fund is a kind of mutual fund. Is the fund manager. So for the mutual fund, you basically they have someone called fund manager who is actually managing the fund, because his guy could go out to buy and sell stocks. And index fund is a very easy way to manage. You just buy whatever is in the index. So, okay. But yeah, the reason we actually bring that into is because what we're learning about exponential growth, and you can see the power of that compound interest because it's exponential growth instead of linear. So before you know it, you end up with not money. Yeah, yeah. So, and here's something you got to be careful nowadays, because today there is a lot of people they have this Marxist viewpoint. They look at things as bad. They don't like capital, so they think that you actually didn't work for your money. Yeah, but they do not understand that money can make money. Okay, instead use our time for them. They think if you work for it, you earn money. That's good, but if you didn't even do any work and you make money, that's bad, and that just that people do not understand how capitalism works. So the reason we live in a capitalist society is because we can use capital to invest, and that makes economy grow, and that also provide jobs for people. If there is no capital, nobody is getting lend money to the people doing business, then we won't have a good economy, and people won't get jobs. Okay, good. All right. Okay, of course, we also have, so this is when we're doing compound interest. And there is something about the compound interest is it also depends on okay, definitely. Socialism really doesn't work. All right. Okay. We go look at okay. Is like we know that if it's in a year, here's our formula. This is our principal, and R is our interest. Early on, we did 4%, which is 0.4. And then this is the time. Now, this is a yearly growth. What happens if you compound quarterly? And this is yearly compound. By end of the year, they will calculate the interest and then put it in there. And if it's the quarterly, that becomes R over 4. And this is for T because we do 4 times over a year. And you could also doing every month. Each month we 12, each year 12 months, that become that. Good. Now, normally when they say the interest, that means annual interest. You'll see why it's called the annual interest. That means when we compound quarterly, then our interest for that quarter is a quarter of that annual interest. If it's monthly, it's 1/12 of that per month. And when we actually get something called continuous compounding is that we are compounding like every second or every fraction of second. We actually get very interesting function. It's called y equal to p and e RQ. Now this is a time we see this interesting number. This is called this number is 2.17 and just never ending. So this is this special number. And so we have this special function that is our base is e, and of course r is on the uh, our variable t is on exponent. So this is a very important exponential function.
I've got a question.
Yep.
Who came up with E?
Euler.
Euler.
Euler is very important mathematician.
Like,
And he
where
was
is
Swiss. He was a Swiss mathematician, but he did most of his work in Russia.
so like what is E derived from?
Well, now we have something called E here because if we continuous compounding, we'll get this. And there's many other ways in we'll get E. Yeah. And I don't know, you probably haven't seen this famous equation. Is actually Euler came up with that is this e to the I is the square root of -1 imaginary number, and pi, of course, we know that's irrational, plus 1 equal to 0. That's Euler's equation. You got e, you got I, you got pi, and when you add 1 equal to 0, or you can think this whole thing here is equal to -1. Okay? Yeah, this is kind of amazing how things you can put together. That, yeah, kind of neat equation we got.
So how would
that makes sense.
What's that?
Okay, I'm gonna try that really quickly.
What?
2.1727 times I is the square root of -1, right?
Yeah. Mm-hmm.
Shoot. Well,
To the power
how,
of,
so would that be to the power of -1 or?
yeah. This actually is, I don't know if your calculator has the imaginary number there. So it's e to the power of I times and pi, and that should give you -1.
Let me see
Let's
here.
see our, I got scientific. Now you do see the E when you calculator, right?
Okay, so that'd be
And
2.17 727.
Oh wait, I times. Right, that makes sense.
I've got E to the X.
and you
Well,
have
pi is irrational, so
the what? Pi is irrational. E is also irrational, and pi is an imaginary number, but -1 is a integer. So all that come together give an integer. So just something quite
How
interesting.
would you find E? I mean I.
I just sort of, well, I actually start with curiosity. It just squares with -1. So what's that? So basically it's trying to answer this question. If x squared is equal to -1,
Oh.
what is x?
Yeah.
Well, we know that x is not any real number. So they came up with this. X equal to square root -1, and that's an imaginary number. Actually, Euler came with, did he came with this notation? I think so. He also
believe so.
notation. Yeah, Euler is very, very important mathematician.
Ooh.
Okay, so now
Yes.
what we got here is this function we write as y equal to p e r t. So when you're doing like continuous compounding on this one, then use this formula. And sometimes we use this one to approximate because it's a lot easier to calculate using this. Uh, okay. Now also, so we see something like this.
Okay.
This is exponential growth. And then what happens? We have function of say half of x. And that actually is, we got half of 2 is 2 to the negative 1 and x. So we got a negative exponent. So this kind of graph, when you're graphing it, you got something going the other way. You go this. You go like this. Good.
Hmm.
So when the y equals to any base, say p to the x, if this positive, if this b is greater than 1, it will be this. And but if b is less than 1, in this case half, it will go down like that. Now this line is called decaying. They call it exponential decay.
Ooh.
And the other one is called exponential growth. Now, where do we see exponential decay? This growth. Exponential decay is when some isotope that say carbon, I think carbon 14, when the amount of carbon 14 in any artifact, say if you are digging something up and find something that looks old, but how do you know how old it is? And well, based on carbon 14, the decaying. And so we basically can back calculate. So say it was like here, then after so many years, now we got to here, then we can back calculate how many years ago. So that's, we use based on the exponential decay, and we use something like carbon 14. This is called carbon dating. So we can actually backdate like something, is that something from 1,000 years ago, or is something from 10,000 years ago? So we can use that. So that's also based on exponential function, but it's instead of exponential growth, we're looking at exponential decay. So
Isn't there like an issue with carbon dating?
yes, it's not that accurate, but
Why?
because there's a lot of, how say, in a way, it's kind of like contamination into it.
Oh yeah, lots of factors.
Yeah, it's kind of like noise, and so it's very hard. But they
Yeah.
definitely can tell something from 1,000 years ago versus 10,000 years ago. But
Yeah.
but if something like say 12,000 versus 10,000, they really just cannot say for, it won't be able to be that accurate. No, but definitely if it's like orders of difference, like 300 years versus 3,000 years, I mean, you pretty much can, can use carbon dating to tell the difference.
Okay.
Okay.
Yeah, that's cool.
All right. Okay, so
Makes
that's
sense.
what we have today. And also we're going to have spring break for the next 2 weeks. Okay. Yeah. And make sure you finish up, make up all the missed homework. And I also will send you our this unit's test. And you can also check on the video recording. And if you need help, just schedule time with me. Okay.
All righty.
Thank you.
All right.
Hey, Dr. Payne, can I ask you a question?
Sure.
Is there like a place where I can see what exactly is missing? So I can see where it is?
What do you mean?
Like I remember you showed us a chart of on like some web page where we could see what we were missing.
It's the grades page. It's on the ThinkWave website. It'll show, go to
Oh.
grades, and then it'll show you all the ones that you've missed. Or go to homework, and it'll show you all the ones you've missed so far.
On what?
Think
What platform was that?
ThinkWave.com.
So it's ThinkWave, and
Yeah.
then
your mom should have that, Jed.
okay. I don't know if she does, but I'll check in with her.
Okay, yeah, it's on the ThinkWave, everything. If you want to check the missing homework, it's there.
Okay. And what would that be under on ThinkWave?
Huh?
What would it be under on ThinkWave?
Oh, I can show you what you're going to see.
Okay.
ThinkWave, let me see. And if you get there, this is what you see. Okay, good.
Okay. Yeah.
Yeah, once you go in there, and you can see under Algebra 2, you can see there.
Okay. So we ThinkWave under Algebra 2.
Right. And you can see that the problem you missed.
Yeah.
And also if you click in, you'll see the homework, the worksheet.
Okay.
Kind of hiding. I don't kind of like that, but that's how they have. You can see, I don't know, there is attachment here. Can you see that?
Yeah,
Yes.
you should be able to on the work page.
Yeah. And also I have the link for the recording for that day.
All righty. Cool. Thank you so much, man.
No problem. Okay.
Thank you very much.
You're
Thank you.
welcome.
Thank you. See ya.
Thank you. Bye.
You have a good one.
For the break.
You too. You have a great break.